Welcome to Ask and Learn.
We want to find the critical numbers of the function f of x equal x to the negative 2 times natural logarithm of x. So we remember the definition of critical number. We say that a number c in the domain of the function f is a critical number of the function if either the first derivative at that number is 0 or the first derivative at that number does not exist. So this is the definition of critical number, and then we calculate the derivative. But first we remember here which is the domain of this function. As we can see, we have this is the same as natural logarithm of x over x squared. So we have the fraction, the division of functions, so it's important that the denominator is not 0, so x cannot be 0, but also the natural logarithm imposes a condition on x to be positive. And in fact, if x is positive, it is already different from 0. And so the general condition of the points x to evaluate correctly this function is that x be positive. So we can say that the domain is the interval 0 plus infinity. That is, the real numbers such that x is positive. That's the domain. And is there in this interval where we look at the critical numbers. By definition, are points or numbers in the domain of the function. So now we calculate the first derivative of f, and we have a product. We are going to use this form instead of this. We use the product here. So we apply the product rule of the derivative, and we get derivative of x to the negative 2 is negative 2x to the negative 3 times the natural logarithm of x plus x to the negative 2 times the derivative of natural logarithm of x, which is 1 over x. And this is the same as negative 2 natural logarithm of x over x cubed plus, then this negative power we put in the denominator and we get 1 over x cubed. So this is the same as 1 minus 2 natural logarithm of x over x cubed. That is, the first derivative is equal to 1 minus 2 natural logarithm of x over x cubed. And so, let's see if there are points in the domain where this derivative is not defined. In fact, we have again natural logarithm of x, which is defined for all positive numbers, and the division, the fraction, is possible when x is not 0. So the two conditions again, x is not 0, x is positive, give us that x must be positive, which include already that x is not 0. So this derivative is defined exists, let's say better, exists for every point or value x in the domain of f, that is, for every positive value x. And that means that we won't find critical points with the condition that the derivative that does not exist. So the only critical points or critical numbers of the given function f are those values, those x positive in the real numbers, such that the first derivative is 0. So we gotta solve the equation f derivative equals 0 for positive values of x. So we start with first derivative equal to 0. It's the same as saying that 1 minus 2 natural logarithm of x over x cubed is 0. And this is the same as saying that 1 minus 2 natural logarithm of x is 0. And that's important to remark that this equivalence implies that we are already at the values of x that are positive. That is, any of these two sides of the equivalence impose this condition because we have the natural logarithm in both of them. And so we have this equation here, which is the same as natural logarithm of x equal to 1/2. And that's the same as e to the natural logarithm of x equal to e to the 1/2 power. And that's the same as, remember, the exponential and the natural logarithm are inverse functions of each other. So that gets 2x equal e to the 1/2 power, and that's square root of e. That is, the only solution of this equation is the positive number x equal to square root of e. So the only critical number of the given function f is x equal square root of e. So it's very important that we find first the domain of the function, then find the derivative, look at where that derivative exists. If there are points in the domain where the derivative does not exist, they are critical points or numbers. And beside that, we got to find where the derivative is equal to 0. So we have done that, and we found only one critical point in this example.